So Dalton's law is pretty important. It helps us do this thing calling collecting gas over water, because we are guaranteed, just like what you saw we got in the last question where we related it to this big table. It's temperature dependent. It's how much pressure the water is also exerting, because that pressure, believe it or not pressure, the water, believe it or not, is evaporating. Right? It's doing this mix of evaporation and then recondensing and evaporation, recondensing. So the water is releasing gas molecules as well. And so depending on the temperature, we see how much the water is releasing. So as you see, if we get really hot, like this right here, this is boiling, we have a pressure of 760. That's crazy, right? That's like atmospheric pressure. Whereas if we have it down here at room temperature, about 25 degrees Celsius, we have it at only 23.8. So you can definitely see that temperature and pressure dependency again, or relationship, just like we're seeing with other things. But if you think about like boiling water, it evaporates a lot. So you have more water molecules that are going to be released, right? And if they're released as a gas and we contain them, they're now hitting the sides of the container. So again, water pressure is going to be temperature dependent, which is why it was so important that we got the temperature of the water in the sink. Okay, now I kind of said that you were going to be using Dalton's law, okay, in order to do this part. Sorry, I should go back to this picture. So the whole idea is that you will always have this pressure total is equal to pressure of your gas plus pressure of your H2O, right? And so what we're looking at when we are doing that, okay, is, so here, I'll write it one more time. Pressure of your gas plus pressure of, of your H2O. Pressure of your gas plus pressure of your H2O, okay? All right, so when we're looking at it this way, we know that this one is temperature dependent, so we're able to collect that. Pressure of the gas, we don't know what that is. We weren't able to stick a little barometer in our tube, right? Okay, and just so you know kind of what this is like the lighter, right? This is the lighter that we had underneath. This is just showing that there's a tube and it is releasing it into the same cylinder idea that we did, right? So this right here, this is our ultimate goal, pressure of gas, okay? We want to know how much that little butane lighter was exerting. And the way that we get that is that we had pressure from the water, right? As water is evaporating a little bit at a certain temperature. We also had pressure total. So if you remember, there was a special step that you guys saw me do. And that was that we had the level down here. I had to raise that little graduated cylinder so that the level was level with the water that was out here. What this took care of was this was taking care of equalizing it with the atmospheric pressure. And so therefore, that volume now is usable, okay? So all that we're going to pay attention to here was the fact that we read it off a barometer, which was our pressure of our atmosphere. Okay, pressure of our atmosphere. We didn't measure it in atmospheres, but we measured it in millimeter mercury. And so that's what we're going to be using for this little step. So partial pressure of dry butane. As you can see, looking here, it says ATM minus H2O, right? So atmosphere minus water. And that is because the total pressure, right? So one more time, pressure total, pressure gas, pressure H2O. The pressure total was our atmospheric pressure. And that was our 760.5 millimeter mercury. And we're setting that equal to, we don't know what our gas was, but we did know that our water was this 17.5. So in order to solve for this guy, we are subtracting that 17.5 under the 760.5. So in the end, we're doing pressure of that gas was equal to 760.5 minus that 17.5. So let's go ahead and calculate that and see what we get. $743. And the units are still millimeter mercury. So we're going to go ahead and put that into our table. Okay. And technically, we have 3 significant figures here, but significant figures we don't really care about is the decimal thing. So the fact that both of these numbers had a decimal tells us that we do have to put 0.0. So 743.0.